Okay, so let us start the class now. Let me brief that what we have covered in the last class. In the last class, we just started discussions about the engine part, and then we mainly focused about the cylinder head constructions point of view and what is why the difference between the size of or diameter difference in the diameter of the intake and the exhaust valves. Mainly that is what we discussed in the last class. So let us move to the further. Okay, we also discussed about the piston and connecting rod assembly. So our next part is to go into the details about the piston. The piston is one of the important parts. All of the parts is the important parts of the IC engine. So if you look carefully about the piston, the top part, this is a piston surface, and above that there is a cylinder head. So the area between the top part of the piston and the cylinder head is called combustion area. The top part of the piston is also called crown. The piston has, if you come back and if you see carefully the curved surface, then what you will find it out that from the top of the piston and then after certain distance there is a groove. Maybe the number of the groove or number of the rings is going to dependent upon the engine to engine and its engine applications, its manufacturer. There are so many parameters that is going to govern about the how many pistons rings are going to be there. So the first ring that is coming that you are seeing from the top surface, that is called compression ring or first compression ring. After that, if there is another ring, that is we also call it second compression ring. So there may be one compression ring, there may be two compression ring, or even you may see that there are three compression ring. It depends upon the so many other parameters. And then at the end, there is a completely different kind of the ring you will see, and that is called oil control ring. Now, in the last class, we discussed that how, because here the combustion is going to be takes place. On the top of the piston, the combustion is going to be takes place, and the pressure inside this area during all the 4A stroke is going to vary widely from atmospheric pressure to around peak combustion pressure. Maybe it vary up to 70-80 bar depending upon the engine and the engine operating condition. So how it is going to be leak proof, particularly here? We know that this piston is going to be inserted into the liner, into the cylinder. So the piston diameter is slightly lower than the liner diameter or bore diameter. Then it's only possible that the the piston is going to be inserted into the bore or in the liner. So the diameter of the piston is slightly lower than the bore diameter. So it means there is, so you may assume that if it is a 80 mm bore diameter, then the diameter of the piston is going to be around 79.5 mm. So there is a gap, but that even a small gap is enough to have a lot of leak if the pressure is going to be more than the 2-3 bar or just even 2-3 bar also. So how we are going to make a leak proof in the combustion area, leak proof the combustion area to the crankcase, because at the bottom here we have a crankcase where the lubricating oil and everything is there. So to make so that is plays the important role about the ring. So what is the ring? So ring is the kind of the sealing, or ring acts as the sealing between the combustion area, between the combustion chamber and the crankcase, and it will not allow to leak the combustion gas from the combustion chamber to the crankcase. Now, even if you see the rings, there is a gap at the end. It is a broken here, here. So there is a broken here. It is not a complete ring. So that gap is really very important. And when your whole assembly is going to be fitted into the cylinder liner, then what will happen? The ring is going to be further compressed, and then thereafter this gap is going to be reduced. And finally, when the whole pistons is going to be inserted into the cylinder liner, the gap, this gap is in the range of 1, or you can say 1.5 max mm, and that is called ring gap. This ring gap is really very important because this ring, even in the during the motion, it has a rotation, several kind of the movement. The rotational movement is it may be slightly, it can go up and down also, and also this ring gap is very important in order to compensate the thermal expansion. So these are the function of the compression ring. And then we have a oil control ring. Oil control ring. This ring controls the thickness of the lube oil on the cylinder line. You will be surprising that even the rings are not in physical contact with the cylinder liner. There is a small thickness, or there is a small there is a lubricating oil of very small thickness that separates the physical contact between the ring and the cylinder liner. There is only possibility to have a slightly physical contact when the piston has its reversal directions, or reverse motions, either at the top dead center or at the bottom dead center, or allow after that there is no physical contact between the ring and the liner. There is a very small lube oil thickness in the order of probably micrometer that separates. If there is a direct physical contact coming between the ring and the cylinder liner, it means the life of the engine is going to be now down, because the wear and tear is going to be takes place, the gap is going to be increased, combustion gas is going to be the leakage, so all sort of the things is going to be takes place. Now, even though you can say that there is a ring gap of 0.5 to 1.5 mm, okay, in the first compression ring, in the second compression ring, there is a gap. So even if at the top of, or in the combustion chamber, if there is a high pressure, then there is a possibility that gas will leak out from this ring gap from the first compression ring. Then it will come to the second compression ring, and then it will go to the crankcase. So in reality, yes, it happens. Very small gas, very small gas, there it leaks out from this ring cap. In order to even further reduce it, what we can do, suppose if we have two compression ring, then the ring gap of first compression ring at this point, then the ring gap of the second compression ring, it may be, we can place it at 180 degree. The phasing between these two gaps is the 180 degree, so that the gap can be further reduced. But yes, there is a possibility that very small gases, still there is a chance that will leak out from the combustion chamber to the crankcase, and therefore If you see the engine very carefully, then there is a pipe coming out from the crankcase to the intake manifold. Later on, we will discuss it even more about that. Then on this part is called piston skirt. If you look from the bottom of the piston, it is a hollow up to the approximately at this point. Only the solid part is maximum from the top part to up to the second or a second compression ring. Then from the bottom, if you look, it is a hollow. It is mainly made of some kind of special kind of the aluminum material. So that's all about the nomenclature of the pistons and the functions. Now, in the last class, as I also told that there is a possibility that you can differentiate between the pistons, that whether the piston belongs to the spark ignition engine or it belongs to the diesel engine. So yes, that can be possible. And at this point, I can tell you only this much, that if you look the piston very carefully and you find that the top part of the piston, that is the crown, it is almost flat. It is almost flat, then it will belongs to the spark ignition engine. But if you see the crown of the piston and if it is having some kind of integrated shape, okay, then you can say that that piston belongs to the diesel engine. But whatever the differentiation I am saying, in general it is true, but under the certain engine conditions that maybe is not going to be true. Sorry, there was a slight disturbance. Okay, so because as I'm saying that the flat part of the piston is belongs to the spark ignition engine, and if the crown has some integrated shape, then it belongs to the diesel engine. This statement is going to hold true in most of the cases, but there is some condition or there is some kind of the engine where this differentiation is not going to be true. But as of now, for this course or in general, we can make such kind of a statement. Now, it's your, or I would like to that you can find it out the answer after some classes, not at this point, because still that to understand the differentiation, that why the shape of the piston, the why the spark ignition engine and the diesel engine has this kind of the piston crown, it needs little bit some more discussion, or when we will go a little bit more about the class, then you will be able to understand. So yes, so that's the what about the piston and the piston rings. Any question here?
Sir, what does the oil control ring do?
Oil control ring controls the lube oil, lubricating oil on the surface of cylinder liner.
Sir, but how and why
Yeah.
is the shape like that?
Yes, that's really very important at how. Now the things is, see the things is, for that part, I don't know whether we are going to find it out the time at the end of the class about the lubricating oil, or how the lubricating oil circulates or controls the temperature or lubrications in all different parts of the engine. Probably we are not going to cover that part, but let me tell you the one things. Um, if you see this crankshaft, okay, this crankshaft is has this kind of the things. It is going to splash the lubricating oil, and it is going to this lubricating oil is also going to fall on the surface of the liner. And then also there is a, if you see this, there is a hole here also, and the connecting rod, this big end, and even in the inside this connecting rod there is a hole through which the oil will reach at the oil oil ring. Okay, and then through these holes it will come out. There are several holes here. These, from these holes the lube oil will come out, and it will be fall on the lube on the cylinder liner surface. The excess lube oil will be scrap out through these rings. So there is a very integrated kind of the galleries in the connecting rod and the piston, through which your the surface of the cylinder liner is going to be lubricated, and the thickness of the lube oil is going to be controlled by the, or excess lube oil is going to be scrapped or controlled with the help of the oil control ring. So that's the mechanism it is going to be.
Sir, why is the shape of piston tapered and what is the function of valve recess?
This one,
Yes, sir.
yeah,
Sir, the
it all, it
piston
is
skirt is also tapered. What is the reason?
what is the reason? Which one? Once again,
Piston
please.
skirt.
Piston skirt, this part. This part?
Yes, sir.
Yeah,
Yes,
because
sir.
it needs, because things is that here we have also things that through which it is going to connect it to the your connecting rod. Okay, that's the one thing. And the piston is cut. This part is also, it is required in order to have some balancing of the piston, and also to in-house this part so that it can be connected to the connecting rod. So that is the one thing. The second thing, as you are asking
Sir, I am
about,
asking why is it in conical shape?
where is the conical shape I was saying? This one?
Yes, sir. The piston skirt, it is seeming like a conical shape.
No, it is not the conical shape. It is circular. Inside that it is circular. Maybe the section, it is not required excess material, it has been cut down. Whatever the excess material, it has been cut down, but the shape of the piston is cylindrical.
Okay.
Okay, the excess material, whatever you can see here at the end of the another end of the piston, it is removed. And the another question is about the valve recess. What you can see here, if you see carefully, there are 4 valve recesses. 1, 2, 3, 4. Here, here, there are 4 valve recesses. It is it might be possible that you cannot see this kind of the valve recess in all sort of the all sort of the pistons. Okay, it all depends upon the manufacturing point of view. But what happens that valve recess, when the piston is reaches at the top, okay, at that time the valve has some kind of the opening. So it is, the valve is going to be extruded inside the combustion chamber. So some space is also provided here in the piston so that the valve should not hit at the surface of the piston, and therefore there is some gap is provided here. So these are the 4 valve recess is, you can see here. It means this piston belongs to a engine which has the 4 valves per cylinder. But it all depends upon the how much is the going to be the combustion chamber or the clearance volume. If the clearance volume is sufficient, or your design of the combustion chamber is in such a way that there is a no chance that the valve is going to hit the piston even if the piston is at the top dead center, then you will not find this valve recess in the crown of the piston. Any question here? If no, then move on. Okay, so at the end, it is your connecting rod, sorry, crankshaft that is at the bottom of the engine, and this end is connected to the connecting rod. Okay, and yeah, so these are the things it is provided in order to balance the connecting rod, or in order to balance the vibration, absorb the vibration of the engine. So that's the only part of you can see here that these are the holes here. Okay, from that what I was saying, that through these holes and the holes in the connecting rod is going to be coincide with each other. So the loop wire, pressurized loop wire, it will be passed on from this point to the your connect to the connecting rod, and then through the connecting rod it will go to the oil control ring. Okay, so with that one, now as we have discussed about the valves, intake valve, exhaust valve, and then we discussed that in the first class also that the valve is going to be open only the part of the cycle, and then it is going to be closed. So it means the valve is going to be open and closed during the cycles. So there must be a kind of the mechanism through which the valve is going to be open and closed at very specific time, because if that specific time is going to be changed, the whole performance of the engine is also going to be affected. So the valve must be open and closed at very specified time. So at what specified time it should be open and closed, that we will discuss later on. Our aim is to study here that what is the mechanism through which the valves is going to be open and closed. That is what the mechanism, our objective. For such kind of there are two kind of the mechanism as of now. We have in the production engine through which the motion of the valves, either the intake valve or the exhaust valve, is going to be controlled. One of the mechanism is called push rod mechanism, and the second one is called overhead cam mechanism. Okay, push rod mechanism and the overhead mechanism. These are the two mechanisms through which the motion of the valve is going to be controlled. Even in these two mechanisms, the overhead cam mechanism is the latest one. Okay, and in most of the, not in most of the, I would say, let us, we can say, or we can make a statement that in most of the passenger, in all of the passenger vehicles, nowadays, the motion of the valve is controlled with the mechanism that is called overhead cam mechanism. This push rod mechanism, it is still in use, particularly in the low speed engine or a stationary engine. Let us, you may say in the tractor, yes, it is still the push rod mechanism, or a single cylinder diesel engine that is used mostly for the irrigation purpose, or sometimes it is used in some small functions to have to generate the electricity also. See, in such kind of low speed engine or a stationary engine, the push rod mechanism is still being used. Now let us study about the first of all the push rod mechanism. Now see this, first of all, this graph, this picture. We have, this is our crankshaft, okay, through which a connecting rod is attached, and another end of the connecting rod is attached with your piston. Okay. On the top of the pistons, we have a valves. One of them will be intake, another will be the exhaust valve. And then here at this point, at this point itself, at this point, there will be cylinder head. So if you remove the cap of the head cover, you will see this spring and this part. Then there is a camshaft. This one is called camshaft. And the camshaft, we have a two cam here because this engine contains two valves. So this camshaft contains two cam. Profile of the cam is going to determine the profile of the valve motion, and the angular phasing between the camshaft and the crankshaft is going to determine the timing that when the valve motion is going to be take place. So what I'm saying is that we have apart from the crankshaft, we have another shaft that is called camshaft. On the camshaft we have two cams here that we can see, and each cam corresponds to the one valve. Since we have a two valves, so there are two cam here, and the profile of the cam is going to determine the profile of the motion of the valve, and the angular phasing between the cam shaft and the crankshaft, it will determine the motion or starting point of the valve actuation. With this cam shaft, if you see, there is a one rod. It is a simple rod that is called push rod. Okay, and this push rod is connected to a rocker arm. That part is called rocker arm, and this is rocker shaft. Rocker shaft is the fixed. Okay, so whenever this profile will move up, and this whenever so this push rod is going to have a reciprocating motion depending upon the position of the cam. So this part is going to be up and down, and therefore this rocker arm is also going to be, when it is going to be rocker push rod is going to be up, then this end of the rocker arm will go down and it will push the valve, and the valve is going to be inside the push down into the combustion chamber. It means this is going to be open condition. So that's the way the valve motion is going to be controlled with the help of the push rod and the camshaft and with the rocker arm. This rocker arm is spring everything. It can be seen from the top of the cylinder head if you can remove its cover plate. Now we know that when we are designing the mechanical, particularly in the dynamic conditions, we try to reduce the mechanical linkage as much as possible. So here, what are the things in order to actuate the motion of the valves? We need to have a camshaft, push rod, rocker arm. These are the mechanism. These are the linkage through which we are controlling the motion of the valves. Now you have to find it out that how we can reduce the linkage, but still we will be in the position to actuate the motion of the valve as per our requirement. If it is possible, that obviously it is going to be the better design than the whatever we have, right, push rod mechanism. In actual situations, you can see here, this is our push rod. This one is the rocker shaft, and this is our rocker arm, spring, and through which the valves are connected. And at the bottom, at this point, we have a crankshaft. When the crank position, when the depending upon the position of the crankshaft, this rocker arm, this push rod is going to be up and down, and this end of the rocker arm is fixed with the push rod. So whenever the push rod will move up, the another end of the rocker arm will go down. It will push the piston, it will push the spring through which the valve is connected. So the valve will go into the combustion chamber. It means it is going to be open condition. So that's the way the valve motion is going to be controlled. Another very important things, as I told in the next class, last class, that it is opened only in the intake stroke and the exhaust stroke. Intake and exhaust correspondingly. Now, there is a correlation between the motion of the crankshaft and the camshaft. And that visually you can also see the size of the gear. So the camshaft rotates at the half of the speed of crankshaft. Okay, because it has to be open only at the certain part. It opens only in the one cycle. Half of the cycle, intake stroke and the exhaust stroke. Then the remaining two stroke, it is the closed position. So the crankshaft, let us suppose the crankshaft is rotating at 1000 rpm. The camshaft will rotate at 500 rpm. So that motion we can, or these relations we can control with the help of our gear mechanism or the size of diameter of the gear. Okay, so I hope there will be some questions from your sides. Please ask the question here. Any question here?
Sir, what is the surface of the wall connecting to the piston looks like?
What you are saying? This one?
Yes, sir.
Here we have a cylinder head that has been removed for this only for the representation here. From this part to up to this part, this is going to be the height of the cylinder head, and it is going to be, even I can show you here. You can see this point. Yeah, this photograph. From here to the here, it is a cylinder head through which we have a valve. This is part of the spring, and this part is connected to the intake manifold. Right now it is closed. When the rocker arm will push the valve will come in and move inside the combustion chamber, and the opening area is going to be clear, and whatever the intake, then fresh air will come into the combustion chamber. Clear here now?
Yes, sir.
Yeah. Now, what do you think? How is there any possibility that we can remove the push rod and the rocker arm? Is there any possibility? And even in that conditions, we can get the valve motions, whatever the lift, how much it has to go in, and when it is going to be opening and closing, we can also achieve all sort of the desired parameters or desired outputs. Is there any possibility? Think about that. How we can achieve it without the push rod and the rocker arm? If we can remove the push rod and the rocker arm. Obviously, it is going to be the very good mechanism because the number of mechanical linkage is going to be reduced. The mechanical vibration, the failure, all sort of the things, the possibility is going to be reduced. So if we can remove the push rod and rocker arm, then what modifications we are going to do so that the valve actuations can be achieved as we are achieving with the push rod mechanism. Any ideas? Any suggestion?
Like the camshaft can be shifted
Camshaft shifted to
above the wall, directly connected to the wall.
wall. Okay, that's really very good. That's a very good idea. That is what you can see here. Overhead cam design. In overhead cam design, again, this is our crankshaft through which connecting rod is connected, and here we have a piston, and then these are the valves. But here, what happens? The valve, we are removing this push rod and the rocker arm, everything, and shifting the position of the camshaft to directly at the top of the valves. And this cam is going to be in contact with the valve like that. So depending upon the lobe design, whenever the tip of the lobe will come, then it will get the maximum lift, and then the other end it is going to be at the closed position. So that design we call it overhead cam design. So now once you remove the cover at the top of the cylinder head, then we can see camshaft and the spring part. In the push rod mechanism, if you remove the cover plate of the cylinder head, then camshaft you cannot see. But here we can see the cam directly. If it is a 4 valves per cylinder, okay, so we need 2 camshaft because both like for this one, for here if we have only 2 valves per cylinder, even if it is a 4-cylinder engine, there is only one camshaft is sufficient to control the motion of the valves of all the cylinder if it is a 2 valves per cylinder. But if it is a 4 valves per cylinder, then we need to have a 2 camshaft so that to control all the 16 valves. The relations between the motion of the camshaft and the crankshaft is obviously it is going to be the same. The relative position of the cams for all the cylinders is at different angle because the intake and the exhaust valve is going to be changed. It's not like that in all 4 cylinders the intake stroke is going to be taken simultaneously in all 4 cylinders. There is a different strokes are going on in a different cylinders, and therefore the relative positions of the cam is also varies because that is what is going to govern that when the intake or the exhaust valve is going to be takes place in what number of the cylinders. So now we have, therefore in the first class itself I told you to go through the some technical specifications of the engine. Even if you have realized or someone of you have gone through that, you will find it out that in the engine a detailed engine specifications it will be written at cam position. So it will be correct OHC. OHC it means overhead cam. those who are in the campus, okay, and if the situation is bit going to be relaxed, then you may visit to the ice engine lab. I will show you. We have a push rod mechanism. We have this kind of the overhead mechanism engine also, especially for you for in order to have a ATF lab, a thermofluids lab. So I can show you whenever you are coming to the ice engine lab. Okay, so these are the two different kind of the mechanism we have in order to get the motion of the valves, push rod mechanism and overhead mechanism. In all the passenger cars, the valve motion is controlled over the with the mechanism of overhead mechanism, but still with the stationary engine or lower speed engine, the push rod mechanism is still going on. Okay. Now, with that one, let me explain the some other nomenclature also. So, in this picture, can you tell me that what is this radius is representing? Now we have a very clear diagram in the 3D engine or 3D part of the engine parts. So in 2D, when I will draw the engine like that, what this radius will represent?
Radius of crankshaft.
Radius of the crankshaft.
Crank length.
Very good. This is the radius of the crankshaft. This is your connecting rod. This part is your piston. Okay. These lines in the piston on the piston is representing the rings. And then this part, what you can see here, this is your cylinder liner. Sorry, this is your cylinder liner. And from here to this part, this is your cylinder head in which we have manifolds. Let us suppose it is a intake manifold. This one is exhaust manifold. And these two lines is representing what? These two lines. What is this one? This line?
Valve.
Valves. Very good. And this is your intake manifold. This is your exhaust manifold. Let us assume. So now when piston is at the top, then that position is called top dead center, TDC. Now we are going to use very frequently. These are the terminology. When piston is at the top, then that position is called top dead center. So whenever we say the piston is at the top dead center or piston is at the bottom dead center, when piston is at the lowest point, at this point, then it is called bottom dead center. And the distance between these two, between the top dead center and the bottom dead center, this length is called a stroke length. And that is what the maximum, this is the motion of the piston. So this is the stroke length. The volume swept by the piston is called displacement volume. So displacement volume is nothing but the stroke length and the area of the cylinder. So that is the volume swept by the piston is called swept volume or displacement volume, and that is termed it as VD. When piston will reach at the top, then whatever the volume remains at the top of the piston, okay, these volumes is called clearance volume. When piston is at the top, then the volume of the combustion area or combustion chamber is called clearance valve. And the total VD plus VC, that is displacement volume plus clearance volume, is called total volume. So in one cycle, let us suppose piston is at the top dead center. Piston is at the top dead center. So this point will be at this here. Then piston will, if it is rotating in a clockwise direction, then piston will come down. Okay, and let us suppose now intake stroke is going on. When piston will move, come down, intake valve will be opens. Okay, and since piston is moving down, it will create the suction. The differential pressure will be created between the intake manifold and the combustion chamber, and because of the differential pressure, the fluid air or air plus fuel is going to come inside the combustion chamber. And then when piston will reach at the top dead center, at that time this crankshaft radius is going to come here. So the effectively the piston crankshaft is going to rotate by 180 degree. Let us assume that intake valve is going to be closed now. I'm saying let us assume it is not going to be closed, but assuming for the simplicity, I'm assuming right now that valve is going to be closed. So the intake valve and the exhaust valve both are going to be closed now. And then again, your crankshaft is going to be rotate. And then what will happen? The piston will move then from bottom dead center to the top dead center. And in that way, the compression stroke is going on. And then when piston will reach at this point, then the crankshaft has rotated now 360 degree. And in that way, your intake stroke and the compression stroke is going to be completed. In the meantime, even towards when the piston is about to reach at the top dead center, the combustion is going to be takes place, and then the pressure and the combustion temperature inside the combustion chamber is going to be increased, and it will push the piston further down. And then the piston will move down from top dead center to the bottom dead center, and then it will again travel to the 180 degree and it will reach here. And then by the time your exhaust valve is going to be open, when exhaust valve is going to be open, the part of the combustion chamber product is going to be flashed out because of the differential pressure, and then the remaining product of the combustion will move out from the combustion chamber by the action of the piston, when piston will further move from the bottom dead center to the top dead center. That is called exhaust stroke. So in that way, your one cycle contains the intake stroke, compression stroke, combustion stroke, and the exhaust stroke. That is there are 4 strokes in one cycle, and in doing so, the piston is moving or the crankshaft is rotating twice, that is by 720 degree. The crankshaft is rotating twice in order to complete one cycle. In one cycle, there are 4 strokes in a 4-stroke engine: intake stroke, compression stroke, combustion stroke, and the expansion stroke. So it has, these are the certain things. It's very clear that in one cycle, the crankshaft will rotate twice, that is by 720 degree. And one cycle, it comprises 4 strokes: intake stroke, compression stroke, combustion stroke, exhaust stroke. What is top dead center? What is bottom dead center? Stroke length, bore diameter, displacement volume, clearance volume, total volume. These are the terminology we are going to now frequently used. Is there any question here?
Sir, can you explain the 4 types of strokes? Intake stroke.
We will explain once again when we will come to the spark ignition engine and the diesel engine, specifically when we are going to discuss. But even in that case, let me explain in the very simple way. Okay, that in realistic conditions it may differ. That initially the piston will be at the top dead center, that is at this point, and we are taking this is as the reference angle 0°. Then when piston will move down, okay, then what will happen at that time? The intake valve will be open. Since piston is moving down, it will create the suction. And in that way, the pressure inside the combustion chamber will fall below the atmospheric pressure. On the top of the here, in this region, the cylinder pressure will be high. So when there will be differential pressure between the intake valve and in the combustion chamber, then the fluid, either it will be air or it is air plus fuel, is going to come into the combustion chamber and it piston will move down. When piston will reach at the bottom dead center, BDC, it means the crankshaft has rotated by 180°, it will reach here. And I'm assuming that at this point, the intake valve is going to be closed. I'm assuming, okay? Then further, crankshaft will move from, or piston will move from bottom dead center to the top dead center. At that time, your both valves are closed. So whatever the contents are inside the combustion chamber, it is going to be compressed, and therefore the pressure and temperature of the content is going to be increased. And by in this way, the piston will move from the bottom dead center to the top dead center, and the crankshaft will complete one rotation. That is, piston crankshaft will be completed 360°. During the compression stroke, when the piston is about to reach at the top dead center, at that time itself the combustion will start. When it will go fully combust, by the time the piston will reach at the top dead center. And at that time, the pressure and temperature inside the combustion chamber will be very high, and therefore it will push the piston further down, and piston will move from top dead center to the bottom dead center. And then again, the second rotation of the crankshaft will be start, and then piston will move from the top dead center to the bottom dead center, and the piston will reach at the bottom dead center. And I'm assuming when the piston will reach about to reach at the bottom dead center, the exhaust valve is going to be opened. At that time, the pressure inside the combustion chamber will be slightly above than the atmospheric pressure. So there will be a pressure differential between the combustion chamber and the exhaust stroke. So the part of the combustion product will going to be flash out through the exhaust manifold. And the remaining part of the combustion product inside the combustion chamber will be flashed out with the action of the piston movement from the bottom dead center to the top dead center. And then again, piston will move from TDC to the BDC and the cycle will repeat. So in order to all these things, what we realized that in order to complete one cycle, the crankshaft will rotate twice, that is 720°, and in one cycle comprises 4 strokes: intake stroke, compression stroke, combustion stroke, and the exhaust stroke. Combustion stroke or expansion stroke you can say also. Even more details we will study in the next class probably.
Excuse me, sir.
Yes.
In the first mechanism, the push down stroke.
Rod mechanism.
Yeah, push rod mechanism. The phase difference between the two cams is 180°, but why is it so? It should be less than that.
It is going to be more clear. Okay, this phase angle between these two cams when we will study about the valve timing diagram. That when the valve opens, is it the valve is going to be open exactly at the bottom dead center, or it is going to be closed exactly at top dead center, or in reality it is going to be even before or after the reference point. These all these things we are going to study in the valve timing diagram. When we will study the valve timing diagram, that when it actually opens and close, then we will be able to realize that what is the and phase angle between these two cams. So hold it right now for this question. Okay, any questions?
Sir, what is the driving force of exhaust stroke?
It is the momentum. It is the momentum, because that's the we have a what we have what is called in the four stroke. Okay, there is only one stroke in which the combustion is going to be takes place. The remaining stroke, the driving force, if you are saying, then if there is a multi-cylinder engine, let us suppose it is a 4-cylinder engine, and as I told it here, that it is that if there is a 4-cylinder engine, then it's not like that the intake stroke, that in all the cylinder the same kind of the stroke is occurring. In some of the cylinder, if the intake stroke is going on, somewhere the compression stroke will go on, somewhere the combustion stroke is going on, and somewhere it is a exhaust stroke is going on. So if it is a 4-cylinder engine, so at least in one cylinder, the combustion stroke is going to be going on, and it is going to take care of the motion of these things. If it is a single cylinder engine or double cylinder engine, then we have a what is called it flywheel. If it is a single cylinder engine, then flywheel is going to act as a driving force. Okay, it will store the kinetic energy and then it will release later on. So that's the way it is going to be the take care the driving force of the remaining cylinders in which the combustion stroke is not going on. Any question?
So, sir, when the engine starts,
Yeah.
so that then we have to give a push to it. No?
Yeah, so that's why when we turn on the key, okay, obviously all the cylinders is at the stationary at that time. So how that now you understanding that when you are turning on the key, then what happens? Then we need to provide the external power or external some kind of the power to the engine. Our engine has to be rotate with using the external power. So that is the part is going to be controlled by the self or motor. When you're turning the key, that motor is going to engage with the with the crankshaft, and it will rotate it for 1 cycle or 2 cycle, whatever, depending upon your control systems. Externally, that power is taken by the battery, through the battery. And once the rotation is going to be takes place, and immediately the combustion is going to be start, and then the motor is going to be disengaged, because once the combustion is going to be starts, the engine will be take care by itself. That is what it is going to be. This kind of the mechanism we have either Activa or we have in the car, where we have a self start. If it is not, then we have a kick that manually through our power we try to first of all rotate the cylinder or rotate the crankshaft. Initially, we have to rotate the crankshaft either through the mechanical power by using our power or through the electrical power. It is clear?
Yes, sir. Thank you, sir.
Okay, so let us close now here. And because we have a lab also at 2 o'clock, group A who has the IC engine lab, please join. I hope everyone has got the link and join the lab at 2:30. Okay.